Okay, so good day everyone. Once again, welcome, and I'm happy to see you all again for this semester. So I just want to share my screen for you to see and for me to discuss the course outline, no, for our course for this semester. So as what I have here, no, so you are DS31, so IT Elect 3, Analytics, Techniques, and Tools. So the syllabus for an analytics, techniques, and tools course might include the following topics. So introduction to analytics, no, the subtopic include definition of analytics and its importance in business, overview of data analytics processes and its steps, types of analytics, so which we already discussed during actually in our introduction to analytics last semester. No, I hope that you still remember those topics, no, that we were able to discuss last time, no, and of course, lesson number 2 focus on data preparation and cleaning. So subtopics includes data types and structures, no? Data collection and methods, data cleaning and pre-processing techniques. For lesson number 3, focus on exploratory data analysis, which covers data visualization techniques, summary statistics, outlier detections. Module number 4, focus on statistical analysis. Subtopics, no, probability and probability distribution, hypothesis testing, confidence intervals, regressions analysis, analysis of variance, no, or ANOVA. Then lesson number 5, that is predictive modeling techniques, cover linear and logistic regression, decision trees, random forests, gradient boosting machines, and neural networks. For module number 6, focus on time series analysis, which covered trend analysis, seasonality analysis, forecasting techniques. Week number 7, or module number 7, focus on optimization techniques. The subtopics are linear and nonlinear programming, integer programming, and network optimization. For module number 8, so focus on machine learning techniques. Subtopics are unsupervised learning techniques, no, clustering and association rules. Supervised learning techniques, decision trees, random forests, neural networks, and so forth, vector machines. Module number 9, focus on text mining and natural language processing. So subtopics, text pre-processing and cleaning, sentimental analysis, and topic modeling. For module number 10, that is big data analytics and tools, Hadoop and Spark, distributed computing, MapReduce. And for week number 11, we focus on visualization tools and dashboard, which covers W or Power BI and data storytelling and techniques. So we need to take note that the specific topic covers in analytics. The next course may vary depending on the level of the course. No, since you are in the undergraduate program, so we utilize this course outline. So the academic institution and the instructor, additionally, the course may include case studies and projects to apply the learned concept and techniques to the real-world problems. Again, there are several types of analytics. No? As what I mentioned, descriptive, diagnostic, predictive, and prescriptive analytics. So, descriptive analytics focuses on summarizing past events and trends, while diagnostic analytics helps to identify the root cause of a problem or issue. So, predictive analytics uses statistical models and machine learning algorithm to predict future outcomes based on historical data, and prescriptive analytics helps to identify the best course of action to take in each situation. There are various examples of analytics that are used in different industries and fields. And here are a few examples. Number one, business analytics. This involves using data and statistical methods to identify trends and patterns in business operations, such as sales and marketing, to make data-driven decisions. Let's say, for example, include customer segmentation analysis, market basket analysis, and forecasting. Number two is the healthcare analytics. So this involves using data to improve healthcare outcomes and reduce costs. Examples include patient outcome analysis, disease prediction models, and population health management. Number three, of course, is the financial analytics. And this involves using data to analyze financial performance and make investment decisions. Let's say, for example, it includes risk analysis, credit scoring models, and fraud detection. Number four, of course, is the sport analytics. This involves using data to analyze and improve performance in sports. Let's say, for example, it includes player performance analysis, team strategy analysis, and injury prevention analysis. Number five is the marketing analytics. And this involves using data to improve marketing campaigns and customer engagement. Let's say, for example, include customer lifetime value analysis, social media analytics, and A and B testing. And number six, of course, is the supply chain analytics. And this involves using data to optimize supply chain operations, such as inventory management, logistics, and transportation. Examples include demand forecasting, supplier performance analysis, and route optimization. These are just a few examples of the many applications of analytics in various industries and fields. Now, how do we define analytics and its importance in business? Analytics is the process of using data, statistical and quantitative methods, and computational techniques to uncover insights and make informed decisions. In business, analytics play a crucial role in helping organizations make data-driven decisions that can improve the efficiency, productivity, and the most important is the profitability. Because analytics allows businesses to gain insights into customer behavior, market trends, and operational inefficiencies. So by analyzing large amounts of data, businesses can identify areas for improvement, reduce costs, and optimize their resources. Let's say, for example, a business can use analytics to identify which products are selling well and which one are not, enabling it to focus on high-performing products and eliminate low-performing ones. Because analytics can also help businesses make more accurate forecasts and predictions about future trends and outcomes. Because by analyzing historical data, businesses can identify patterns and trends that can help them make more informed decisions about future investment, resource allocation, and strategic planning. Moreover, analytics provide businesses with the ability to measure the success of their strategies and initiatives. By tracking key performance indicators, or the KPIs, and metrics, businesses can determine whether their strategies are effective or need to be adjusted. Now, analytics is important in business because it helps organizations make data-driven decisions that can improve their operations and bottom line. By gaining insights from data, businesses can identify opportunities for growth, optimize their resources, and make more informed decisions about their future. Now, overview of data analytics processes and its steps. And the data analysis process typically involves the following steps. Number one, defining the problem. Understanding the business problem or questions that needs to be answered. Number two, data collection. Collecting relevant data from various sources, including internal and external sources. So, number three is data preparation, cleaning, transforming, and structuring the data to make it ready for analysis. Next will be the exploratory data analysis. This one is analyzing and visualizing the data to understand the patterns and relationship. Another is statistical analysis. Now, using statistical method to draw insights, make inferences from the data. Then, predictive modeling. So, building models to predict future outcomes or behaviors based on historical data. We have prescriptive analytics, which provide recommendation or suggestions for action based on the insights and prediction from the data. Okay, so this time I just want to share the types of analytics. As I mentioned, we have descriptive, diagnostic, predictive, and prescriptive. There are four main types of analytics, as I mentioned, and each type of analytics serves as a specific purpose in the data analysis process and can be used to gain insights into different aspects of a business or organization. So, as what we discussed last time, descriptive analytics involves analyzing historical data to understand past events and identify patterns and trends. This type of analytics is often used to summarize and report on data in a meaningful way, such as through charts, graphs, and tables. Descriptive analytics is used for gaining insights into a customer behavior, market trends, and operational efficiencies. Let's say, for example, a retailer may use descriptive analytics to analyze sales data from the previous year to understand which products were the most popular and which ones sold poorly. Another is the diagnostic analytics. It involves analyzing data to identify the root cause of a problem or issue. And this type of analytics is often used to understand why certain events or outcomes occurred and to identify areas for improvement. Diagnostic analytics is useful to identify problems in a business or organization, such as process inefficiencies or customer dissatisfaction. Let's say, for example, an organization may use diagnostic analytics to identify why its customer retention rates have dropped, such as poor customer service or a lack of product innovation. Another is the predictive analytics. Predictive analytics involves using statistical models and machine learning algorithms to analyze data and make predictions about future events or outcomes. And this type of analytics is often used to forecast future trends and to identify potential risks and opportunities. So predictive analytics is useful for businesses and that want to be proactive in their decision-making and take action before problems occur. Let's say, for example, an organization may use predictive analytics to forecast future demands for a product, enabling it to adjust production and inventory levels accordingly. Prescriptive analytics, on the other hand, involves using data and mathematical models to identify the best course of action to take in a given situation. This type of analytics is often used to optimize business operations and improve decision making. Prescriptive analytics is useful for businesses that want to maximize the resources and achieve their goals efficiently. Let's say, for example, an organization may use prescriptive analytics to determine the most efficient route for a delivery truck to take based on traffic patterns and other factors. And to summarize the discussion of our module number 1, each type of analytics serves as a specific purpose in the data analysis process, and it can be used to gain insights into different aspects of a business or organization. Descriptive analytics helps to understand past events and identify patterns. Diagnostic analytics helps to identify the root cause of the problem. Predictive analytics helps to forecast future trends and outcomes. And prescriptive analytics helps to identify the best course of action to take in a given situation. I just want to share a video presentation which help you to understand more about the data analysis process.
Hi, my name's Will, and I'm going to give you a step-by-step guide to the data analysis process. Let's go. In this video, we're going to go through the 5 key stages of the data
process. We're going to give you an overview and an introduction to each of these stages, as well as looking at some of the tools you'll use to undertake these stages. So let's dive into step 1, defining the question. The first step in your data analysis process or any define your objective. In data analytics terms, this is called the problem statement. Defining your objective means coming up with a hypothesis and figuring out how exactly to test it. You can start by asking, what business problem am I trying to solve? Now, I know this might sound straightforward, but it can actually be trickier than it seems. For instance, your organization's senior management might pose a question such as, why are we losing customers? It's possible, though, that this doesn't get to the core of the problem. A data analyst's job is to understand the business and the business's goals. As a data analyst, you need to understand this in enough depth that they can frame the problem the right way. To give you a practical example, let's say you work for a fictional company. For example, we'll call it Top Notch Learning. This fictional company, Top Notch, creates custom training software for its clients. In this example, Top Notch is excellent at securing new clients. But unfortunately, Top Notch has much lower repeat business. As such, as a data analyst, your question might not be why are we losing customers, but which factors are negatively impacting the customer experience? Or even better yet, how can we boost customer retention whilst minimizing costs? Now you've identified the problem, you need to find which data is going to help you solve this issue. This is where your business acronym comes in again. For instance, perhaps you've noticed that the sales pipeline for new customers is very slick, but the production team is extremely inefficient. Knowing this, you could hypothesize that the sales process actually wins a lot of new clients. But the customer experience, well, it's kind of lacking. Could this be the reason that customers aren't coming back? What sources of data will help you answer this question? As a data analyst, considering all these things will help you define the question and help you solve the problem at hand. There's also a number of tools that can help you define your objective. Defining your objective is mostly about soft skills, so business knowledge and lateral thinking. But you'll also need to consider business metrics and key performance indicators, and these are called KPIs. Monthly reports can help you track problem points in the business. There are lots of tools out there on the market that can analyze this business data. Tools like Databox and Dasheroo. There's also free open source software like Grafana, Freeboard, and Dash Builder. These are fantastic for producing simple dashboards, both at the beginning and at the end of the data analysis process. So that was step 1, defining the objective. On to step 2. Step 2, collecting the data. Once you've established your objective, you'll need to create a strategy for collecting and aggregating the appropriate data. A key part of this is determining which data you need. This might be quantitative data or numeric data, e.g. sales figures or monthly reports, or qualitative, descriptive data, such as customer reviews. All of this data fits into one of 3 categories: first party, second party, and third party data. Let's explore each one briefly now. What is first party data? First party data is data that you or your company has directly collected from customers. It might, for example, come in the form of transactional tracking data or information from your customer relationship management system, your CRM system. Whatever its source, first party data is usually collected in a clear and structured way. Other sources of first party data might include customer satisfaction surveys, focus groups, interviews, or direct observation. Let's talk about second-party data. To enrich your analysis, you might want to secure a secondary data source. Second-party data is simply the first-party data of other organizations. This might be available directly from the company or from a private marketplace. The main benefit of second-party data is that it's usually structured, and although it's less relevant than first-party data, it tends to be reliable. Examples of second-party data include website, app, or social media activity, like online purchase history or shipping data. So lastly, what is third-party data? Third-party data is data that has been collected and aggregated from numerous sources from a third party. Often, but not always, third-party data contains a lot of unstructured data or big data. Many organizations collect this big data to create industry reports or to conduct market research. The research and advisory firm Gartner is a good real-world example of an organization that collects big data and then sells it on to other companies. Open data repositories and government portals are also sources of third-party data. Let's take a moment to look at some of the tools that you can use to collect data. Once you've devised a data strategy, i.e. you've identified what data you need and how best to go about collecting it, there are many tools that you can use to help you. One thing you'll need, regardless of industry or area of expertise, is a data management platform, or DMP. A DMP is a piece of software which allows you to identify and aggregate data from numerous sources before then manipulating them, segmenting them, and so on. There are many DMPs available. Some well-known enterprise DMPs include Salesforce DMP, SAS, and the data integration platform Xplenty. If you want to play around, you can also try some open source platforms like PIMCore or DSwarm. On to step 3, cleaning the data. Once you've collected your data, the next step is to get it ready for analysis. This means cleaning or scrubbing it, and this is crucial to make sure that you're working with high quality data. Key data cleaning tasks include removing major errors, duplicates or outliers, all of which are problems when you aggregate data from numerous sources. Removing unwanted data points, so extracting irrelevant observations that have no bearing on your intended analysis. Bringing structure to your data or general housekeeping, so for example fixing typos or layout issues, which will help you map or manipulate your data more easily. And finally, it helps filling in major gaps. As you're tidying up, you might notice that important data is missing. Once you've identified these gaps, you can go about filling them. A good data analyst will spend about 70% to 90% of their time cleaning data. This might sound excessive, but focusing on the wrong data or analyzing erroneous data will severely impact your results. It might even send you back to square one. So whatever you do, don't rush this step. Let's have a look at some of the tools that you can use to clean your data. Cleaning data manually, especially large data sets, can be incredibly daunting. But luckily, there are many tools available to streamline this process. Open source tools such as OpenRefine are excellent for basic data cleaning, as well as high-level exploration. However, free tools offer limited functionality for very large data sets. Now, I know this sounds like a data zoo, but Python libraries such as Pandas and some R packages are better suited to heavy data scrubbing. You will, of course, need to be savvy with the languages. Alternatively, enterprise tools are also available. For example, Data Ladder, which is one of the highest highest rated data matching tools in the industry. There are many more. Why don't you see which data cleaning tools you can find online? Share your free tools in the comments below. So that was step 3, cleaning the data. On to step 4, analyzing that data. Finally, once you've cleaned your data, now comes the fun bit, analyzing it. The type of data analysis you conduct largely depends on what your goal is, but there are many techniques available. Univariate or bivariate analysis, time series analysis, and regression analysis are just a few you might have heard of. More important than the different types, though, is how you apply them. This depends on what types of insights you're hoping to gain. Broadly speaking, all types of data analysis fit into the 4 following categories. Descriptive analysis, which is analysis which identifies what has already happened. This is a common first step that companies do before proceeding with deeper explorations. Diagnostic analysis, where the focus is on understanding why something has happened. It is literally the diagnosis of a problem, just as a doctor uses the symptoms to diagnose the patient's disease. Predictive analysis, which is where you identify future trends by the analysis of historical data. Predictive analysis is commonly used by businesses to forecast future growth. And lastly, prescriptive analysis, which allows you to make recommendations for the future. This is the final step in the analytics part of the process, but it's also the most complex. This is because it incorporates aspects of all the other analyses that we've described today. Step 5, sharing your results. You've finished carrying out your analyses, you have your insights. The final step of the data analysis process is to share these insights with the wider world, or at least with your organization's stakeholders. This is actually more complex than just sharing the raw results of your work. It involves interpreting the outcomes and presenting them in a manner which is digestible to everybody that's in the room. Since you'll also present your work to decision makers, it's very important that the insights that you share are 100% clear and also unambiguous. For this reason, data analysts usually use reports, dashboards, and interactive visualizations to support their findings. How you interpret and present results will often influence the direction of the business. Depending on what you share, your organization might decide to restructure, to launch a new product, or close an entire division. That's why it's very important to present all the evidence that you gathered and not to cherry-pick data. Ensuring that you cover everything in a clear and concise way will prove that your conclusions are scientifically sound and based on facts. On the flip side, it's important to highlight any gaps in the data or to flag any insights that might be open to interpretation. Remember that honest communication is an important part of the process. It will help the business, but it will also help you to excel at your job. There's a ton of tools for interpreting and sharing your findings. These tools are suited to different experience levels, but popular tools that require no coding skills include Google Charts, Tableau, Data Wrapper, and Infogram. If you're familiar with Python and R, there are also many data visualization libraries and packages available. For instance, check out the Python libraries Plotly, Seaborn, job. There's a ton of tools for interpreting and sharing your findings. These tools are suited to different experience levels, but popular tools that require no coding skills include Google Charts, Tableau, Data Wrapper, and Infogram. If you're familiar with so many data visualization libraries and packages available. For instance, check out the Python libraries Plotly, Seaborn, and Matplotlib. Whichever data visualization tools you use, make sure that you polish up your presentation skills too. Visualization is great, but communication is key. So hopefully now you have a better idea of the data analysis process. Career Foundry have an awesome data analytics short course, and you can sign up for free via the link in the description. Thanks for joining us today.
Okay. So to summarize all the discussions, no, most companies are collecting loads of data all the time, but in its raw form, this data doesn't really mean anything. This is where data analytics come in. So the data analytics is the process of analyzing raw data in order to draw out meaningful, actionable insights which are then used to inform and drive smart business decisions. So a data analyst will extract raw data, organize it, and then analyze it, transforming it from incomprehensible number of numbers into coherent, intelligible information. Having interpreted the data analyst will then pass on their findings in the form of suggestions or recommendations about what the organization's next steps should be. You think of data analytics as a form of business intelligence used to solve specific problems and challenges within our organization. It's all about finding patterns in a data set which can tell you something useful and relevant about a particular area of the business. How certain customer groups behave. Let's say, for example, how employees engage with a particular tool. Because data analytics helps you to make sense of the past and to predict future trends in behavior. Rather than basing your decisions and strategies on guesswork, you're making informed choices based on what the data is telling you. Armed with the insights drawn from the data, businesses and organizations are able to develop a much deeper understanding of their audience, their industry, and their organization as a whole. And as a result, are much better equipped to make decisions and plan ahead. So, maybe somebody are asking what the difference between data analytics and data science. Data science and data analytics tend to be used interchangeably. However, they are two different fields and denote two distinct career paths. What's more, they each have a very different impact on the business or organizations. One key difference between data scientists and data analytics lies in what they do with the data and the outcomes they achieve. A data analyst will seek to answer specific questions or address particular challenges that have already been identified and are known to the business. To do this, they examine large data sets with the goal of identifying trends and patterns. They then visualize their findings in the form of charts, graphs, and dashboard. And these visualizations are shared with key stakeholders and used to make informed, data-driven strategic decisions. On the other hand, a data scientist considers what questions the business should or could be asking. They design new processes for data modeling, write algorithms, devise predictive models, and run custom analysis. Let's say, for example, they might build a machine to leverage a data set and automate certain actions based on that data, and with continuous monitoring and testing. And as new patterns and trends emerge, improve and optimize that machine whenever it's possible. Now, in short, data analysts tackle and solve discrete questions about data, often on request, revealing insights that can be acted upon by other stakeholders, while data scientists build systems to automate, and optimize the overall functioning of the business. Another main difference lies in the tools and skills required for each role, because data analysts are typically expected to be proficient in software like Excel and, in some cases, querying and programming languages like SQL, R programming, SAS, and Python. Analysts need to be comfortable using such tools and languages to carry out data mining, statistical analysis, database management, and reporting. Data scientists, on the other hand, might be expected to be proficient in Hadoop, Java, Python, machine learning, and object-oriented programming, together with software development, data mining, and data analysis. Despite their differences, it's important to recognize that data science and data analytics work together, and both make extremely valuable contribution to business. Okay? No, so what are the different types of data analysis? No, we discussed it already actually. No? So as what we discussed earlier, descriptive, diagnostic, predictive, and prescriptive. So descriptive, what happened? Diagnostic, why did it happen? Predictive, what is likely to happen in the future? and prescriptive, what's the best course of action? So, again, descriptive analytics is a simple, surface level type of analysis that looks at what has happened in the past. So the two main techniques used in descriptive analytics are data aggregation and data mining. So the data analyst first gathers the data and presents it in a summarized format. No? That's the aggregation part. And then mines the data to discover patterns. The data is then presented in a way that can be easily understood by a wide audience. Of course, for those who are not just data experts. So, it is important to note that descriptive analytics doesn't try to explain the historical data or establish cause and effect relationship at this stage. It's simply a case of determining and describing the what. Descriptive analytics draws on descriptive statistics, which you can learn, of course, about in our lesson. Then, diagnostic analytics. Now, while descriptive analytics looks at the what, diagnostic analytics explore the why. When running diagnostic analytics, data analysts will first seek to identify anomalies within the data. That is anything that cannot be explained by the data in front of them. Let's say, for example, if the data shows that there was a sudden drop in sales for the month of March, the data analyst will need to investigate the cause. So to do this, they'll embark on what's known as the discovery phase, identifying any additional data sources that might tell them more about why such anomalies arose. And finally, the data analyst will try to uncover causal relationship. Let's say, for example, looking at any events that may correlate or correspond with the decrease in sales. At this stage, data analysts may use probability theory, regression analysis, filtering, and the time series data analytics. The third one is the predictive analytics. No? Just as the name suggests, predictive analytics tries to predict what is likely to happen in the future. Predict ang future. And this is where data analysts start to come up with actionable, data-driven insights that the company can cause to inform their next steps. Predictive analytics estimate the likelihood of the future outcomes based on the historical data and probability theory. And while it can never be completely accurate, no, it does eliminate much of the guesswork from key business decisions. Predictive analytics can be used to forecast all sorts of outcomes from what products will be most popular at a certain time to how much the company revenue is likely to increase or decrease in a given period. Ultimately, predictive analytics is used to increase the business chances of hitting the mark and taking the most appropriate actions. The last one is the prescriptive analytics. Building on predictive analytics, prescriptive analytics advises on the actions and decisions that should be taken. In other words, prescriptive analytics shows you how you can take advantage of the outcomes that have been predicted. When conducting prescriptive analysis, data analysts will consider a range of possible scenarios and assess the different actions the company might take. Prescriptive analytics is one of the more complex types of analysis and may involve working with algorithms, machine learning, and computational modeling procedures. However, the effective use of prescriptive analytics can have a huge impact on the organization's decision-making process and ultimately on the bottom line. So the type of analysis you carry out will also depend on the kind of data you're working with. Again, the type of analysis you carry out will also depend on the kind of data you're working in. So If you are not already familiar, it's worth learning about the 4 levels of data measurement: nominal, ordinal, interval, and ratio. So, actually, data analytics has a case study about healthcare and some other aspect. We have also a case study about Netflix, no? And this will be your asynchronous task, no? You need to study about the data analytics case study of healthcare and data analytics case study about Netflix. So, what does a data analyst do? Let's say, for example, after your graduation, and you're considering a career as a data analyst or thinking about hiring one of your organization, you might be wondering what task and responsibility fall under the data analyst job title. In an interview discussing what it's actually like to work as a data analyst are, of course, as a graduate of data analyst or IT with a specialization in business analytics or data analytics. And of course, the role of data analyst means different things to different companies. However, there are some common threads that you'll find among the most data analyst job description. Based on the real job ads, no, there is a typical task and responsibility of a data analyst. Number one, if you are a data analyst, you are the one who is responsible to manage the delivery of user satisfaction surveys and report on results using data visualization software. Work with business line owners to develop requirements, define success metrics, manage and execute analytic projects, and evaluate results. Monitor practices, processes, and systems to identify opportunities for improvement. Proactively communicate and collaborate with the stakeholders, business units, technical teams, and support teams to define concept and analyze needs and functional requirements. Translate important questions into concrete analytical tasks. You need also to gather new data to answer client questions, collating and organizing data from multiple sources. You are also responsible to apply analytical technique and tools to extract and present new insights to client using reports and or interactive dashboards. No? You are also relay complex concepts and data into visualization. Collaborate with data scientists and other team members to find the best product solution. You are required to design, build, test, and maintain back-end code. You need to establish the processes, define data quality criteria, and implement data quality processes. You are required to take ownership of the code base, no, including suggestions for the improvement of refactoring, build data validation models, and tools to ensure data being recorded is accurate, and work as a part of a team to evaluate and analyze key data that will be used to shape future business strategies. So, what is the typical process that a data analyst will follow? Of course, no, define the question, collect the data, clean the data, analyze the data, and visualize and share your findings, as our video presentation discussed earlier. No? So, what are the most commonly, or what tools and techniques do data analysts use? No? Much like web developers, data analysts rely on the range of different tools and techniques. So, data analysis, analytics techniques. No? Before we introduce some key data analytics techniques, let's quickly distinguish between the two different types of data you might work with. No, maybe you're also finished with your research one. So quantitative and qualitative. And it's already discussed actually in our introduction to business analytics. Quantitative data is essentially anything measurable. For example, the number of people who answered yes to a particular question on a survey, or the number of sales made in a given year. Qualitative data, on the other hand, cannot be measured and comprises things like what people say in an interview or the text written as part of an email. Data analysts will usually work with quantitative data. However, there are some rules out there that will also require you to collect and analyze qualitative data. So it's good to have an understanding or both. So with that in mind, some of the most common data analytics techniques are regression analysis, factor analysis, or what we call dimension reduction, cohort analysis, cluster analysis, time series analysis. We're going to discuss all those things though for the entire semester. And these are just a few of the many techniques that data analysts will use. And we're only scratched the surface in terms of what each technique involves and how it used. Some other common techniques include Monte Carlo simulation, dispersion analysis, discriminant analysis, and text or content analysis. So the latter being a technique for analyzing qualitative data. First, and the data analytic tools, no, the tools that a data analyst might work with. So if you're looking to become a data analyst, you'll need to be a proficient in at least some of the tools that I will mention later. No, but if you're never ever heard of them, don't let that deter you. Like most things, getting to grips the tools as the trade is all part of the learning curve. No. Number one, of course, Microsoft Excel, W, SAS, RapidMiner actually, no, and Power BI. So, if you wanted to be a data analyst, no, what skills do you need to become a data analyst? In addition to being well-versed in the tools and techniques we've explored and discussed a while ago, no, data analysts are also expected to demonstrate certain skills and abilities which they'll often learn while studying a course of data analytics. No? And some of the most important hard and soft skills you need to become a data analyst. Number one, mathematical and statistical abilities, because data analysts spend a large portion of their time working with numbers. So it goes without saying that you'll need a mathematical brain. Number two, knowledge of programming languages such as SQL, Oracle, and Python. As we've seen, data analysts rely on a number of programming languages to carry out their work. This may seem daunting at first, but it's nothing that can be learned over time. Number three, an analytical mindset. It's not enough to just crunch the numbers and share your findings. Data analysts need to be able to understand what's going on and to dig deeper if necessary. It's all in the name. Analytical mindset is a must. No? Keep problem-solving skills. Data analysts have a wide variety of tools and techniques at their disposal. And the key part of the job is knowing what to use when. And remember, as data analytics is all about answering questions and solving business challenges, and that requires some keen problem-solving skills. And the last, of course, you need to have an excellent communication skills. Once you've harvested your data for valuable insights, it's important to share your findings in a way that benefits the business. So data analysts work in close collaboration with the key business stakeholders and may be responsible for sharing and presenting their insights to the entire company. So if you're thinking about becoming a data analyst, it's important to make sure that you're comfortable with this aspect of the job. Excellent communication skill. So, maybe somebody are asking, what are some of the best data analytics courses? Okay. As more and more companies recognize the importance of data, data analytics has becoming something of a buzzword. With that, we've seen a whole host of courses and programs emerging with focus on teaching data analytics from scratch and ultimately facilitating a career change into the field. It's a great time to be an aspiring data analyst. So what courses are worth considering? Course, the Career Foundry Data Analytics Program, the Springboard Data Analytics Bootcamp, and the Certified Analytics Professional Credentials. So what does the future hold of data analytics? Maybe right now you're just only third-year student or fourth-year student or second-year student. Data has become one of the most abundant and valuable commodities in today's market. You'll often hear about big data and how important it is. However, when it's often claimed that data is the new oil, it is important to recognize that data is only valuable when it's refined. The value of the data that a company has depends on what they do with it, and that's why the role of the data analyst is becoming increasingly pivotal. Still, the sheer value of data or data analytics is reflected in the way the market has surged in the recent years. Right? Actually, in 2019, the global data analytics market was valued 49 billion US dollar. No, that more than double what was worth in 2015 and 2020 to 2023, and the market is expected to grow at the rate of 30% per year, taking it up to 77.6 billion US dollars. So what does this mean in terms of career prospect? So at the time of writing or this discussion, a search for data analyst jobs, of course, turned to 20,000 vacancies in US alone. And we can expect this figure to rise according to the report published by the World Economic Forum. Data analysts will be one of the most in-demand professional in 2020 and beyond. So if you're considering a career in data analytics, there has never been a better time. As the market grows and business face a significant skill shortage, data analysts will increasingly benefit from high demand, a rich variety of opportunities, and competitive compensation. And since you are enrolled in a data science, looking forward that you will be luckily hired and earn billions of dollars. So, there you have it. A complete introduction to the fascinating field of data analytics. We've covered a lot of information from fundamental tools and techniques to some of the most important skills you need to master if you want to become a data analyst. So if you're brand new to the field, all these skills and requirements, not to mention the technical terminology, can seem overwhelming, but it's important not to let that put you off. Remember, data analytics is a rapidly growing field, and skilled data analysts will continue to be in a high demand. With the right training, anyone with a passion and determination can become a fully fledged, job-ready data analyst, keen to learn more about analytics, and, of course, success is in your way. Okay, so I think that's it for module number 1. And congratulations in advance.